Okay, guys, I wanted to go over your Science Unit 10 Lesson 2. It's about what are magnets, and you're also going to be doing 2 strands of IXL for this about how magnets attract and repel. And some of you may have already done this because I put it on last week's IXL, and then I realized when I went to start filming this video for next week that I didn't want to do IXL this week. So if you did it, you're done with it, and yay. Lucky you. I know it was only a few people like Noah and Logan, I think. So we're pretty good. I caught it early. All right, so what are magnets? On this page, we see 3 big magnets, and look at all this black stuff around here. Those are iron shavings, and iron shavings are something that magnets will attract. And maybe you've played with a toy before that has like a face on it, and you can drag the magnet shavings up with like a magnetic little stick and make like a mustache and eyebrows on the people. I know those were pretty popular toys when I was younger, and I know my kids have played with them a little bit, but you don't see them too much, but maybe you know what I'm talking about. But also there's lots of other kinds of magnet toys that are out there that use this kind of technology. When Noah was younger, he had this like a board, and it had magnet shavings underneath, and you could draw, and then you can just erase it by moving the like a little tab on it. It erases it, and you can rewrite. It's kind of like, and like an Etch-a-Sketch, I think, uses magnets. I think, don't quote me on that because I might be wrong there, but there's a lot of magnet technology, and magnets are used for everything, like from as simple as putting something on your refrigerator, like an important piece of paper or a recipe or something, or to like, I hang your name tags on your lockers. I hung those with magnets. To big things like industrial things, like I know some of the roller coasters and rides that we like to ride at Cedar Point when my family goes there are controlled with magnets. So magnets can be small and used all the way to huge objects in science and industry and technology and all that business, engineering. So the first thing for Engage Your Brain, what objects are making this smiley face? Well, I already said what these are, so hopefully you're paying attention. So write the word there. On the active reading, you guys are going to write 4 vocabulary words. Make sure you spell them correctly, and they're the highlighted words in the chapter. All right. First page talks about magnetic pull. A magnet is an object that can pull things made of iron and steel. A magnet can push or pull other magnets. A magnet has 2 poles. A pole is a place on a magnet where the pull is the greatest. One pole is the north-seeking, or N pole, so N stands for north, and the other pole is the south-seeking, or S pole, and S means south. So magnets have 2 ends, north and south ends. Find the sentence that tells the meaning of pole, draw a line under it. So pole right here, a pole is a place on a magnet where the pull is the greatest. So I don't have any bar magnets here at home, but I do have some magnets like this, as simple as a refrigerator magnet. So this is just a magnet, and this disc has this side, and obviously there's a side that's glued to the other, to this little button thing. So one of them would be the North Pole, one of them would be the South Pole. Noah, grab me a magnet. Yeah. This is tank tops and bell bottoms. Noah is very proud of this coloring. It hangs on our fridge. All right, so here I have another magnet, and I want to see, so to make magnets attract to one another, you have to have a North Pole and a South Pole. So you have to have opposite poles to attract. And then if you have the same poles, they repel. So let's see if these 2 attract. Ooh, these happen to attract. They stick to each other. Give me a few other magnets up there, Noah. Maybe even the chip clip one. So these are opposite poled magnets because they will stick to each other. I bet I know if I took this magnet off of this, the hot glue was off of it, and I turned it around, they would go like this. There would be resistance. They couldn't push together. So let's see. Here's another magnet. This one doesn't even attract at all. So let's see. The kids are pulling all the magnets off the fridge. That attracts. That attracts. Attracts. I guess we have no magnets that don't attract each other. Should all of these attract? I wanted to show you what it looked like if they didn't attract. Looks like I don't have any to show you, so maybe that attracts the way. It's just too heavy. Okay. So maybe at home you might have some bar magnets that would attract. I should have grabbed some stuff from school, but I didn't think about it. So, but if you had two magnets that were opposite poles, there would be resistance and they would not attach to each other. Okay. So on here we see some different types of magnets. We see bar magnets, we see a horseshoe magnet, and we see ring magnets. And then on this page it says that like poles or poles that are the same repel each other, and repel means to push away. So like I was just showing you, none of my magnets repelled each other, but if we had the same poled magnets towards each other, they would never connect. You could try with all your might and push, but the magnet is way too strong for you. You could, even the strongest person in the world could not get two magnets with the same poles to attract. It can't be done. Okay. So on this one it says draw two bar magnets to show another way they can repel. So look at, they attract when they're opposite and they repel when they're the same. Well, up here we have two north poles. So if we have two magnets down here, what do I have to label them as? Here I have the ends, the north ones that repel, so I'm going to do the opposite. I'm going to do the south on the inside. So if the south poles were put together, they wouldn't attract either. So then the north would be on this side, okay? And then, so we see the poles that attract, they will stick together. Opposite poles or poles that are different attract each other. Attract means to pull towards something. All right. Attract attention. A steel paper clip is attracted to a magnet. A rubber band is not. Magnets attract some things, but not others. Look at these boxes. Which things are attracted to a magnet? So I brought a few things. So we see a lot of things here. We see a paper clip, a tack, a screw, a washer, a barrette, and a safety pin. So I have a screwdriver here, and it attracts. And then I have this paper clip. Does the top part attract? Yep, even the top is metal. Look at a spatula. Attracts. And then some things that wouldn't attract, like my pen, it doesn't attract. Zoe's little baby elf, TJ, he doesn't attract. Nope. He's not magnetic. An Easter egg doesn't attract. All right. I guess a squid. The squid doesn't attract. Stop messing with me. All right, so draw something else that a magnet attracts. So I'm going to draw my spatula because I thought that was a really good one. You can draw something else that you want to draw, or you can take my idea. That's fine. So there's my spatula. And obviously this is a metal spatula. We also have a rubber, like plastic one, and it wouldn't attract that. It only attracts the metal ones, right? So if you had a metal cooking spoon, it would attract that too, or some tongs, right? All right, draw something else that a magnet does not attract. So some things that don't attract here, we have, I don't know if this is a Cheerio or if it's like a rubber washer. Like this was a metal one, it might be a rubber one. Or it could be a Cheerio, I don't know. We have a piece of string. We have a penny. Even though a penny is hard like a metal, it's not magnetic. It's because of the it's copper or other materials that make it up, not anything magnetic. Knock it off. Sorry, my kids are bothering me. A button a popsicle stick, and a jack. Now this is a plastic jack. There are metal jacks, and a magnet would attract a metal jack, but this is a plastic jack. So TJ wants me to draw him. So I guess I'm getting a little, I'm gonna trace him. You guys can draw whatever you want. I'm just gonna draw his little face. There's TJ, the Christmas elf. Okay, so obviously you can draw whatever you want. Like a noodle is not gonna attract, a piece of bologna is not gonna attract, some dog kibble, a leaf. These are things that would not attract because they're not magnetic, right? All right, next page. Look at the way the magnet pulls the paper clips right through a hand. A magnet does not have to touch an object to move it. This is possible because of its magnetic field. This is the area around a magnet where the magnetic force is felt. So my magnet is not strong enough to pull through my hand, but if you had a super powerful one, you could do this. So maybe you have this at home. If you're able to do this at home, if you want to take a picture and send it to me, I'll give you extra credit, okay, in science, because I think that's pretty cool. So the magnetic field is the area around the magnet that will have enough energy in it to attract something to it. So there's a little experiment here. Do the math. It says, how far from a paper clip must a magnet be before it does not attract it? Use a ruler to measure. So I'm going to move my paper up here a little. And I have a paper clip, and I have my ruler, and I have my magnet. So first it says 1/2 inch. So there at the 1/2 inch mark, oh, it's hard to see, sorry guys. Here at the 1/2 inch mark, I have my paper clip. So if I put the magnet right here, oh, my magnet's so not strong. It's not gonna attract it, darn it. Well, this is a bust. Okay, so I don't have a strong enough magnet. Maybe this one will. Let's see if this one does. It's close, but I have to lean it in. So you know what? I'm just going to tell you what happens here, because I have my teacher's book to show us. So the magnet will attract at 1/2 inch if it's strong. And a magnet will attract at 1 inch if it's strong. But anything over that, it's not going to attract. So the magnetic field is 1 inch. So my teacher's book says, well, I guess it would depend on your magnet strength. See, my magnet strength was not great, and you might not have one that's great either, so maybe none of them will work. But if you had a strong, powerful magnet, it could work. The magnet attracts the paper clip when it's 1 inch or closer to the magnet. It doesn't attract the paper clip at the distances greater than 1 inch. So mine barely worked at 1/2 inch. So you know what? If you guys did this and you were able to come up with something, just show me your information. But if you copied mine, I'm going to say the magnet, the magnetic field was 1/2 inch. So actually, I'm going to say no on mine, because this was my magnet. Other magnets are going to be different, but the magnetic field was 1/2 inch. How do I know? Because it wouldn't attract the paper clip over 1/2 inch away. Unfortunately, but if you had a really super strong magnet, you maybe could get it to attract the 2 inches. So if you were able to do this experiment at home and you had a really powerful magnet, tell me about it. So if you answered yes to all these, your magnetic field would be 2 inches because it could attract 2 inches away. So you're just going to tell me that. But if you didn't, or if you didn't have magnets at home to use, you can use my information, okay? All right, so I'm going to stop with the video for today. You guys can be done with science today, and catch up on more tomorrow. But if you want to definitely finish it today, you can go ahead and go see the next video. See you then.